All right, let's continue with functions. Last video was basically an overview of the basics of functions. Here we're sticking with that idea and going over things about what we call function notation. So first of all, f of x means a function of x. In other words, we have a situation that all operates based on one variable called x. Just like here, 2x plus 3. That is a function about x. And I want you to get used to the notation. So it's got f of negative 3. So that means we just plug it in and we solve it and we get negative 6 and 3. And then we get negative 3. So what that means is the function at negative 3 actually comes out to be also negative 3. So the x value is negative 3, and the y value is also negative 3. Let's do absolute value. Do you remember how those work? Is that once you've simplified the absolute value bracket, it basically asks you the question, how far are you from 0? It doesn't, that's why it's always positive. So f of negative 4 would mean a negative 4 in there. And then that simplifies to negative 6. That comes out as 6 and 3. And so we get negative 4 and 9. So one of the misconceptions about absolute value is people want to turn it positive right away. Notice I did all the math inside first, and then it came out as positive 6. The x value was a negative 4, and the function, or the y value, is at 9. Now this is input getting the output. This is the input getting the output. You can also go backwards through the process. I can give you the output and say, what was the x that made that happen? Let's practice that. So here, notice it says the function at x equals 10. It doesn't say f of 10. It says the function is now at 10. What is the x value? So this is working backwards. So if you wrote it out, 2x plus 3, and then it says the function's value is 10. So I say, oh, the function is at 10. What is x? So I get 7, and I get 3.5. So the x value was at 3.5 to obtain a y value or a function value at 10. Same thing over here is that if I was at 15 and I had x minus 2 plus 3, let's subtract 3 from both sides is 12. Now this guy's actually a little tricky, but let's just do some thinking. I think it's fairly obvious that 14 would be one of our answers, because 14 minus 2 is 12. And then the other answer is the negative 12 answer. We could also put in negative 10, because negative 10 and negative 2 make negative 12, and that would work. The way you can solve those is you basically solve this problem, which gives you the 14, and you solve this problem, which gives you the positive 10 or the negative 10 there. Okay, let's move along here for a second. The last part of this is function machines, which is just a tricky way to, or not a tricky way, but a different way to work with functions. This is your machine. You have an input and an output, and you got an input, you throw it in there, you throw your 1 in the machine, whoop, out comes 7. You throw a 2 in the machine, and 2 times 2 is 4, boop, out comes 9, and so on. Very simple. The nice thing is when you have inputs, you plug them in, and out come the outputs. It can go the opposite way as well. So let's just take a quick look at 1 or 2 of these, and then we'll call it a done video. And off you go. So this time, they've got a pattern already created of inputs and outputs, and you're to come up with the formula. Now, watch what happens. 1, 1, 1. That's easy. Wait a minute. Not that easy. So it is increasing by 1, but if I put in my 1 there, I get 2. Wait a minute. So I actually need this to look like this. The constant change of 1 is here, and then I increase by 3. So if I put in a 1 now, I get 4. If I put in a 2, I get 5. Ah, I see what's happening. Let me show you the trick. 5, 5, 5, and so on. So what it means is the constant increases by 5. And then you got to kind of tweak it to make it work. So if I put in a 1, I just get 5. But I need to get a 6, so I need to add 1. Let's see if that works for the 11. If I put in a 2, that's 10. 11. Perfect. Let's do one more. Increase by 3, increase by 5, increase by 7. This is a little trickier. When they're not increasing in a regular rate, well, here's what we could do. Notice that they're at the second layer. The first layer, it's changing. At the second layer, it's back to fixed. If it happens in the first layer, it's a linear problem like this one. If it happens in the second layer, it's an exponential. And this is actually the answer, I think. 1 squared, 2 squared, 3 squared, so on. I better do one more. 3, 3, 3, perfect. 3x. Notice constant change, 3x. And then I got to make it work. If I put in a 1, I get 3. I need a 5. It's getting easier. Good luck with this.